Rocket Lab, Past, Present and Future. Introduction. Founded in 2006 by Peter Beck in Auckland, New Zealand, Rocket Lab has carved a niche in the global space industry as a pioneer in providing small satellite launch services. The company has shifted from its initial focus on propulsion systems to become a leading developer of launch vehicles, primarily known for its Electron rocket. Rocket Lab's mission is to simplify access to space, catering to commercial, civil, and defense sectors. Historical overview. Early years 2006 to 2014. Rocket Lab was established with the vision of developing advanced rocket technologies. In 2009, the company made history by becoming the first private entity to reach space from the Southern Hemisphere with its ADA-1 rocket. The company continued to innovate and in 2014 announced the Electron launch program, designed specifically for small satellite launches. This marked a significant pivot towards the burgeoning small satellite market. Technological breakthroughs. The Electron rocket is notable for its use of the Rutherford engine, which was the first oxygen/hydrocarbon rocket engine to utilize additive manufacturing 3D printing for all its primary components. This innovation not only reduced production costs but also expedited development times. The first successful launch of the Electron took place in 2016, establishing Rocket Lab as a key player in the space launch sector. Current operations. Achievements and growth 2021 to 2023. As of early 2023, Rocket Lab has successfully completed over 80 missions and deployed more than 200 satellites into orbit. The company operates from several facilities, including advanced manufacturing and mission operations centers in the US and New Zealand. In 2021, Rocket Lab expanded its launch capabilities by opening a new site at Wallops Island, Virginia, and announced the development of the Neutron rocket, aimed at launching larger payloads. The Electron rocket has gained recognition as the second most frequently launched U.S. rocket, reflecting Rocket Lab's commitment to providing reliable and frequent launch opportunities. The company has successfully executed missions for various customers, including NASA, the U.S. Department of Defense, and numerous commercial entities. Future directions. Upcoming innovations. Looking ahead, Rocket Lab is set to revolutionize the small satellite launch industry further with its Neutron rocket, which is designed to support larger payloads and constellations. The Neutron will also incorporate reusability features to enhance cost-effectiveness and efficiency. Additionally, Rocket Lab is focusing on initiatives like the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) programs, aimed at streamlining development costs and improving launch responsiveness. Strategic partnerships. Rocket Lab continues to leverage public-private partnerships to enhance its technological capabilities. Collaborations with various government agencies and commercial partners are critical for advancing its propulsion technologies and launch systems. The company's strategic approach aims to lower barriers to entry for satellite operators and expand the overall space economy. Conclusion. Rocket Lab's journey from a small startup to a significant player in the space launch industry exemplifies the potential of innovation and entrepreneurship in the aerospace sector. As the company continues to push the boundaries of technology and launch capabilities, it remains committed to its mission of making space accessible and affordable for all. Looking towards the future. Rocket Lab is well positioned to lead the charge into a new era of space exploration and satellite deployment. Counterintuitive insights about Rocket Lab. 1. From propulsion to launch services, it may seem intuitive that companies in the aerospace sector start with a focus on launch services. However, Rocket Lab began primarily as a propulsion systems developer. This focus on propulsion technology laid the groundwork for its later success in launching small satellites, challenging the traditional pathway many aerospace companies follow. 2. Small satellite focus in a large industry. While the aerospace industry has historically been dominated by large payloads and massive rockets, Rocket Lab's success stems from its focus on small satellites. This counterintuitive approach allowed it to carve out a niche market as many commercial and government clients sought dedicated, frequent launches for smaller payloads, a space often overlooked by larger launch providers. 3. 3D printing in rocketry. The use of 3D printing in the creation of the Rutherford engine was groundbreaking. While many industries are cautious about adopting additive manufacturing due to concerns regarding reliability and material integrity, Rocket Lab embraced it, fully producing the world's first 3D printed rocket engine. This move not only reduced production costs but also accelerated the design and testing phases, defying conventional wisdom that high-stakes aerospace components require traditional manufacturing methods. For frequent launches as a competitive advantage, in an industry where launches can often be delayed or scheduled far in advance, Rocket Lab's commitment to frequent launches is seen as a significant advantage. This approach counters the traditional model of large and frequent launches and has allowed Rocket Lab to build a reputation for reliability and responsiveness, which is increasingly appealing to customers. 5. Investment from diverse sectors. Rocket Lab's funding came from various sectors, including traditional venture capital, aerospace giants like Lockheed Martin, and government contracts. This diverse funding model is counterintuitive in the aerospace industry, where companies often depend heavily on government contracts or private equity. Rocket Lab's ability to attract investment from multiple sources has provided it with the flexibility to innovate and expand. 6. Transition from small to large rockets. The development of the Neutron rocket marks a pivotal shift for Rocket Lab, moving from small satellite launches to supporting large payloads and constellations. This transition might seem counterintuitive as companies typically scale up gradually. Rocket Lab's leap into larger rocket development reflects its confidence in its technological advancements and market opportunities, aiming to compete with established players in the large launch market. 7. Public-private partnerships, PPP, as a growth strategy. Rocket Lab's success in leveraging PPPs, particularly with entities like the Air Force Research Laboratory (AFRL), demonstrates a counterintuitive strategy in which a private company utilizes public resources and expertise to enhance its technological capabilities. This collaboration allows Rocket Lab to innovate rapidly without bearing the full burden of research and development costs, which is not commonly pursued by many aerospace firms. 8. Focus on reusability in a small rocket market. While many large aerospace companies are investing heavily in reusability to reduce costs, Rocket Lab's emphasis on reusing components of its smaller rockets is less common. This strategy challenges the notion that reusability is only cost-effective for large rockets and demonstrates a forward-thinking approach to sustainability and efficiency in launches. 9. Response to market needs. Rocket Lab's development of responsive space access initiatives like the Affordable Responsive Modular Rocket (ARMR) showcases a counterintuitive shift from traditional aerospace timelines to a more agile market-responsive model. This focus on rapid deployment capabilities challenges the slow, methodical processes that have long characterized the industry. 10. A broad service offering. Rocket Lab has expanded its services beyond launch vehicles to include spacecraft manufacturing and on-orbit management. This integrated approach contrasts with the trend of companies specializing in single areas. By offering end-to-end solutions, Rocket Lab positions itself uniquely in the market, addressing the full spectrum of customer needs and potentially increasing customer loyalty. Conclusion. Rocket Lab's journey from a propulsion-focused startup to a significant player in the space industry challenges many traditional assumptions about aerospace development funding and operational strategies. Its counterintuitive decisions, from embracing 3D printing and focusing on small satellites to developing larger rockets and utilizing public-private partnerships, illustrate a dynamic approach to innovation and market responsiveness, setting a precedent for future aerospace ventures. Rocket Lab has become a notable contender in the space industry since its inception in 2006. While many highlight its achievements, such as the successful launches of the Electron rocket and the development of the Neutron rocket, there are several important aspects of the company's journey and future endeavors that are often overlooked. These elements reveal deeper insights into Rocket Lab's strategic positioning and its impact on the broader space economy. 1. Strategic partnerships and collaborations. One critical aspect that many reports gloss over is the importance of Rocket Lab's public-private partnerships (PPPs) and collaborations with various government and commercial entities. The Air Force Research Laboratory (AFRL) has played a pivotal role in developing advanced propulsion technologies that Rocket Lab utilizes. This synergy not only accelerates technological advancements but also enables Rocket Lab to leverage established expertise and infrastructure, thus reducing development time and costs. Significance: these partnerships are essential for fostering innovation and minimizing risks associated with new technology developments. They enhance Rocket Lab's credibility within the industry and provide a competitive edge in securing government contracts, particularly in the defense and satellite sectors. 2. Focus on small satellite launches. Though the Electron rocket is frequently recognized for its reliability and frequency of launches, the broader implications of Rocket Lab's focus on small satellite launches are often overlooked. The rise of small satellites has transformed the space landscape, enabling a new class of companies and organizations to access space. Rocket Lab's commitment to this sector has made it a key player in democratizing access to space. Significance: by focusing on small satellite launches, Rocket Lab is not just catering to current market demands, it is also shaping future trends in satellite technology and deployment strategies. This foresight positions the company advantageously as the market for small satellites continues to grow, potentially leading to a more extensive customer base and sustained revenue streams. 3. Innovations in manufacturing and technology. Rocket Lab's use of 3D printing technology, particularly with the Rutherford engine, represents a significant technological leap that is often underappreciated. The ability to manufacture rocket engines using additive manufacturing reduces costs and production times significantly compared to traditional manufacturing methods. Significance: this innovation not only enhances Rocket Lab's operational efficiency but also sets a precedent for the aerospace industry. As competitors look to replicate this success, Rocket Lab's early adoption of such technologies could establish it as a leader in manufacturing practices, influencing industry standards and expectations. 4. Comprehensive space solutions. While many focus on Rocket Lab's launch capabilities, the company's broader vision of being an end-to-end space solutions provider is frequently overlooked. Rocket Lab does not just launch satellites, it also designs and manufactures spacecraft, provides satellite components, and offers on-orbit management services. Significance: this holistic approach allows Rocket Lab to tap into multiple revenue streams and reduce dependency on launch services alone. It positions the company as a comprehensive partner for clients, facilitating long-term relationships and increasing customer loyalty. 5. Future of responsive space access. Rocket Lab's initiatives to develop responsive space access capabilities through projects like the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) are often overshadowed by its current offerings. These projects aim to enhance rapid deployment and operational flexibility in response to dynamic market needs. Significance: as geopolitical tensions rise and the demand for rapid data and satellite capabilities increase, Rocket Lab's focus on responsive space access could make it a crucial player in national security and defense. This foresight aligns with the growing trend of militarizing space and emphasizes Rocket Lab's potential role in future defense strategies. 6. Global expansion strategy. Rocket Lab's strategic expansion from its origins in New Zealand to the United States and beyond is a significant milestone that is sometimes understated. Establishing a presence in multiple locations, including advanced manufacturing facilities in Virginia and New Mexico, allows Rocket Lab to cater to a diverse clientele and tap into various regional markets. Significance: this geographical diversification not only mitigates risks associated with operational disruptions in a single location but also enhances the company's ability to respond to local demands and regulatory environments. as the global space economy expands. Rocket Lab's strategic positioning will enable it to capitalize on international opportunities. 7. Environmental considerations. While the focus is often on technological advancements, Rocket Lab's commitment to sustainable practices in launching and developing its rockets is sometimes overlooked. The company's approach to minimizing the environmental impact of rocket launches is increasingly relevant as public scrutiny on space activities grows. Significance. By prioritizing sustainability, Rocket Lab can appeal to environmentally conscious customers and stakeholders, enhancing its reputation and marketability. Furthermore, as regulatory bodies worldwide begin to impose stricter environmental guidelines, Rocket Lab's proactive stance could provide a competitive advantage. Conclusion. In summary, while Rocket Lab's achievements in launching rockets and developing new technologies are well documented, several critical components of its strategy and operations deserve more attention. The company's focus on strategic partnerships, small satellite launches, innovative manufacturing practices, comprehensive space solutions, responsive access, global expansion, and sustainability initiatives are all pivotal to its current and future success. These elements not only underscore Rocket Lab's role as a leader in the space economy but also highlight its potential to shape the future of space access and utilization. As the company continues to evolve, its ability to navigate these factors will be essential in maintaining its competitive edge in a rapidly changing industry. 1. Innovative propulsion technology. Rocket Lab's development of the Rutherford engine, the first oxygen/hydrocarbon engine utilizing additive manufacturing for all primary components, signifies a groundbreaking approach in propulsion technology. This innovation not only enhances performance and reliability but also sets a precedent for the future of rocket manufacturing. The engine's design reflects Rocket Lab's commitment to utilizing advanced manufacturing techniques, which could lead to reduced costs and increased efficiency in rocket production. Analyzing the implications of such technology could provide deeper insights into the future of space propulsion and its impact on the broader aerospace industry. 2. Market position and business strategy. Rocket Lab has strategically positioned itself as a leader in the small satellite launch market, becoming the second most frequently launched U.S. rocket with its Electron vehicle. The company's focus on making space access affordable and frequent has resulted in over 80 successful missions and the deployment of more than 200 satellites. This business model emphasizes the importance of cost-effective launch solutions in the growing space economy. Examining Rocket Lab's market strategy, including partnerships and customer diversification, can reveal key factors contributing to its sustained growth and competitiveness in a rapidly evolving industry. 3. Future directions with Neutron rocket. The introduction of the Neutron rocket represents Rocket Lab's ambition to expand its capabilities beyond small satellite launches to larger payloads and complex missions. This shift not only signals Rocket Lab's response to market demands for larger constellations and interplanetary missions but also reflects the company's innovative edge. Analyzing the engineering, design, and potential applications of the Neutron rocket can provide a deeper understanding of how Rocket Lab plans to address future challenges in space exploration and commercial satellite deployment. 4. Public-private partnerships and technological advancements. Rocket Lab's collaboration with government entities and private industry has been pivotal in transitioning advanced propulsion technologies to commercial applications. The company's engagement with initiatives like the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) highlights the importance of strategic partnerships in fostering innovation. Delving into these public-private partnerships can shed light on how they contribute to technological advancements, improve launch responsiveness, and enhance the overall capability of the U.S. space launch infrastructure. This analysis can also explore the broader implications of such partnerships for future space missions and national security interests. Famous historical cases similar to Rocket Lab. 1. SpaceX, founded 2002. Founded by Elon Musk. SpaceX has significantly transformed the aerospace industry and commercial spaceflight. Its Falcon 1 rocket became the first privately developed liquid-fueled rocket to reach orbit in 2008. SpaceX further revolutionized space travel with the Falcon 9, known for its reusability, significantly reducing launch costs. The company has expanded its focus beyond launch services, developing the Starship vehicle for missions to Mars and beyond, similar to Rocket Lab's Neutron project aimed at larger payloads. 2. Blue Origin, founded 2000. Established by Jeff Bezos, Blue Origin has been a key player in the space industry, focusing on suborbital and orbital spaceflight. Its New Shepard system is designed for suborbital space tourism, while the New Glenn rocket aims to compete in the orbital launch market. Like Rocket Lab, Blue Origin emphasizes reusability to lower costs and increase launch frequency. The company's vision includes enabling millions of people to live and work in space, paralleling Rocket Lab's mission to make space accessible. 3. North American Aviation, 1940s to 1960s. North American Aviation (NAA) was a significant aerospace manufacturer known for its contributions to military and civilian aviation. NAA developed the F-86 Sabre, which played a crucial role in the Korean War. The company later merged with Rockwell International and became involved in the Apollo program, contributing to spacecraft design and development. Like Rocket Lab, NAA's innovations in propulsion and aerospace technology were pivotal in shaping the industry. The legacy of NAA's advancements in aerospace parallels Rocket Lab's evolution from propulsion systems to comprehensive space solutions. These cases illustrate how innovation in aerospace, driven by visionary leadership and technological advancements, has shaped the industry's landscape, similar to Rocket Lab's trajectory in the modern space economy. Future outlook for Rocket Lab, predictions for 2025 and beyond. Rocket Lab, having established itself as a key player in the global space industry through its innovative approach and commitment to making space accessible, is poised to expand its influence significantly in the coming years. This outlook explores the anticipated developments and strategic directions for Rocket Lab from 2025 onward. 1. Expansion of launch capabilities, the Neutron rocket. Rocket Lab's development of the Neutron rocket marks a pivotal shift towards accommodating larger payloads and more complex missions. Expected to debut in the late 2020s, Neutron will support a broader range of applications, including launching large satellite constellations and interplanetary missions. This will position Rocket Lab to compete directly with larger launch providers like SpaceX, especially in the realm of dedicated rideshare missions for megaconstellations, which will become increasingly prevalent as global demand for satellite services grows. 2. Increased frequency of launches. As Rocket Lab continues to refine its Electron rocket and ramp up production capabilities, the company is likely to achieve a launch cadence that could rival that of any commercial launch provider. By 2025, Rocket Lab could be conducting multiple launches per month, driven by increasing demand from commercial, civil, and defense sectors. The establishment of additional launch sites in the U.S. and internationally will facilitate this growth, enabling Rocket Lab to offer more flexible and responsive launch solutions. 3. Enhanced spacecraft solutions. In addition to launch services, Rocket Lab is set to enhance its range of spacecraft solutions. The company's Photon satellite platform is expected to evolve, supporting a wider variety of mission profiles, including lunar and Martian explorations. By leveraging lessons learned from past missions, Rocket Lab will likely introduce advanced spacecraft technologies that enhance the capabilities of its satellites, including improved propulsion systems and autonomous operations. 4. Partnerships and collaborations. The future will see Rocket Lab forging strategic partnerships with both governmental and commercial entities. Collaborations with NASA and the U.S. Department of Defense are expected to deepen, particularly in areas requiring rapid and responsive launch capabilities. These partnerships will not only enhance Rocket Lab's credibility but will also provide access to vital funding and technical resources, positioning the company as a go-to provider for national security and scientific missions. 5. A focus on sustainability. As the space industry faces growing scrutiny over its environmental impact, Rocket Lab is anticipated to lead initiatives focused on sustainability. This may involve developing greener propulsion technologies and adopting practices that minimize space debris. The company's ongoing commitment to reusability through its Electron rocket program will also be central to these efforts as Rocket Lab seeks to reduce costs and environmental footprints associated with space launches. 6. Technological innovations in propulsion. Rocket Lab is likely to continue pioneering advancements in propulsion technology, particularly with its ongoing research into hybrid and alternative fuel systems. The potential integration of innovative designs like the rotating detonation rocket engine RDRE could significantly enhance performance metrics, making launches more efficient and cost-effective. These advancements will solidify Rocket Lab's reputation as an innovator in rocket technology. 7. Growth of the space economy. The overall growth of the space economy will benefit Rocket Lab significantly. As more industries recognize the utility of space-based services, from telecommunications and Earth observation to internet access and scientific research, the demand for reliable launch services will surge. Rocket Lab is well positioned to capture a significant share of this expanding market by leveraging its established reputation and diverse service offerings. 8. Responsive launch services. Rocket Lab's initiatives aimed at providing responsive launch capabilities will gain traction. The Affordable Responsive Modular Rocket ARMR program will evolve, allowing Rocket Lab to offer on-demand launch services that can meet urgent requirements from both commercial and government clients. This capability will likely become a cornerstone of Rocket Lab's business model, appealing to customers needing immediate access to space. 9. Global expansion and market penetration. In the coming years, Rocket Lab will likely continue to expand its global footprint. By establishing more launch facilities outside of the US and New Zealand, the company will enhance its ability to serve international clients and tap into emerging markets. This expansion will not only diversify its revenue streams but also increase its competitiveness on a global scale. 10. Focus on education and outreach. As Rocket Lab continues to grow, it is expected to enhance its educational outreach efforts. Engaging with the next generation of engineers and scientists through internships, scholarships, and partnerships with educational institutions will be pivotal. By cultivating talent in STEM fields, Rocket Lab can ensure a steady pipeline of skilled professionals who will drive future innovations in the space sector. Conclusion. The future of Rocket Lab appears bright, with numerous opportunities for growth and innovation on the horizon. By 2025, the company is set to solidify its position as a leader in the space economy, driven by strategic advancements in launch capabilities, technological innovations, and a commitment to sustainability. As the demand for space access continues to rise, Rocket Lab's proactive approach will enable it to remain at the forefront of the industry, paving the way for a new era of space exploration and commercial opportunities.